All right, let's move on here. We're going to talk about what's called the Babylonian Soros cycles. The word Soros is a Babylonian word, and NASA still uses it today when talking about eclipses. Real basic. Here's the Earth, here's the Sun, here's the Moon, here's the equatorial line, here's the ecliptic line, and this green line represents the line of the Moon's orbit. The Moon's orbit is roughly about 5 degrees angled off of the ecliptic line. Your nodes would actually be right here. This is the point where eclipses would actually take place. Here's your North Pole, your South Pole, angled at 23.5 degrees. So here's your ecliptic line, here's the equatorial line, and here's the lunar orbit line, angled at 5 degrees off of the ecliptic line. Let's move to this over here. Again, here we have the Earth and the Sun. The Earth and the Sun. This circle right here represents the orbit of the Moon as it goes around the Earth. Okay, it's an elliptical orbit, meaning that it's not a perfect circle. What is interesting about this orbit is that as the Moon goes around the Earth, okay, and it crosses over the nodal points, the orbit itself, in other words, the path that the Moon takes around the Earth, the orbit itself also moves as well. So you kind of have like this egg shape that comes all the way around like so and comes this way, like so. That causes these nodes to spin like this, okay? So when it comes back, when the Moon comes back to its nodal position at the right time, the orbit will have actually moved a little bit. You'll see the orbit apex is here, and then over here we have the orbit apex here. The total time it takes for the lunar orbit to actually go around the Earth is a total of 18.2 years. That's the lunar path orbit, okay? We have the nodes go around like this. When the nodes cross the Earth and the Sun and they're on the ecliptic plane, when they're in this position, you actually have a solar eclipse. And then when they're in this position over here, you actually have a lunar eclipse. Put it up on a line. Here's the ecliptic line, just like this, okay? And then the path that the Moon takes is across here. And as this circle orbits around like this, in other words, this egg shape moves like this, okay? Over time, what ends up happening is when it gets back to its point, 18.2 years later, the nodes have moved. They'll move every 18.2 years, and so the nodal path goes this way. So here you got one point right here, 18.2 years later, another point here, another point here, another point here. So roughly, you'll have an eclipse at the same nodal point every 18.2 years. However, because it's moving across the ecliptic line, the eclipse is not going to be in the same exact position in terms of the constellations. It's going to move like this, okay? So you'll have an eclipse here at this point. Let's say this is the one that took place on August 21st, right at Regulus. Next time it comes around, 18.2 years later, it'll have moved closer, it'll move in this direction, and this direction, and eventually it ends up over in Virgo and continues to keep going. What is interesting about this is that there's what we talked about, the Soros cycle. The Soros cycle is the cycle that the eclipse actually takes over a number of years. The whole cycle takes about 1,300 years. Each cycle will have an average of 70 eclipses in them, coming around every 18.2 years. On average, there are 40 Soros cycles taking place at any point in time. The reason for that is because eclipses will start either at the South Pole or the North Pole. They will start their 1,300 plus or minus year Soros cycle at the South Pole or the North Pole, and as it's moving across this plane like this, because this orbit is moving, okay, as it's moving across, every time it comes back and does an eclipse, it's moved, and it moves in this direction, and up if it starts at the South Pole, okay? And that actually goes all the way around the Earth. If it starts at the North Pole, it'll move down, okay? And that actually goes around the Earth. This is very important when we get to the next video, which we're going to try to put everything up on the board and explain to you how the dragon came into being and all the elements related to it. So again, this is what we call the Babylonian Soros cycle. It takes place about every 18.2 years. That's the distance between eclipse and eclipse per Soros cycle. But there are 40 different cycles going on at the same time. Some are starting down to the North Pole or the South Pole or the North Pole. Some of them, like the one we just saw, are up in the above the equator. So there are 40 of these going on at any point in time, and their average is about 1,300 years, with an average of 70 eclipses, 40 solar cycles, and an eclipse about every 18.2 years per Soros cycle. Thank you. We'll go on to our next video.